everyone. Today we'll be discussing some symbols which are used in mathematics. So this session is essentially for the people who are beginning, people who feel that they are not good in mathematics, people who get confused in the symbols. This is in a series of sessions. This is the first one in which I'll be discussing the symbols that are majorly used in mathematics. It is very helpful for all the MBA entrance exams. So let's start it. The learning outcomes for today's session will be you'll be able to know different symbols used in mathematics, and it will also be a confidence booster for the beginners. So let us go one by one. The first thing is basic numeracy. So here you must have heard about BODMAS. I have used BIDMAS. Now, what does it mean? So when you use BODMAS, O stands for order. Order is like order of a number, square, cube, to the power 1 by 2, to the power 1 by 3. So whenever the power is a fraction, for example, 1 by 2, it becomes square root. It's 1 by 3, it becomes cube root. Power is 1 by n, it becomes nth root. So these are the orders. They're also known as index, the plural is indices. So first of all, we will start applying the brackets first. So if we have a huge expression in which there are a lot of elements, bracket is also there, any index is also there, division, multiplication, addition, subtraction. So the order of preference will first will be solving brackets, then the indices, then the division, then multiplication, then addition, and then subtraction. So, by the way, even in brackets, we have three different kinds of brackets. First bracket is this, the simple bracket. Then we have a curly bracket, and then we have a square bracket. So, in the order of preference, this should be solved first, then this, and then this. For example, if you have something like this, 2 plus 2 plus 2 plus 3. So, if it this is the expression. So, first of all, we'll solve this bracket, that is 5. So it becomes 2 plus 5. We'll remove the bracket. Now we have curly only. 2 plus 7. So that is how we're going to solve. Just for the example, I have shown you how to prefer the brackets. Simple, curly, and square. By the way, these brackets can have other meanings as well, which we'll be discussing in the upcoming slides. Let's move on to the next slide. Here I have given you an example. So as you can see, what all things are there. We have a bracket, of course. We also have this division. We have an index that is square. So now we can solve it. So first of all, whatever is inside the bracket, we'll solve that first. So index will be the first preference. Then we'll go to addition. The 2 square is 4 plus 3 is 7. And there's a open the bracket, get the answer as 2. It's simple. It's very simple. We just have to always understand that first start with bracket, then go to index, division, multiplication, addition, and subtraction. Now, I want you to solve this and tell me in the comments that what will be the correct answer. 15 divided by 5 plus 3 square is what you have to solve. Tell me in the comments. Well, now set theory and algebra. So this is a chapter, a unit, I can say, an entire module in which there will be a lot of symbols which we need to understand to get the grasp completely. So first is equal to. This is the symbol, very easy, like 2 is equal to 2, great. 2 is equal to 4 divided by 2, and all that stuff. Equivalent to. So whenever we use three horizontal lines, this means equivalent to. So it's not equal, but it's equivalent. That means something which is very much similar. By the way, to get the usage of this, whenever we will be doing, when we using these symbols in the real chapters, we'll be able to get to know that what is equivalent and what is equal. Equal means exactly same. Equivalent means similar. All right. That is almost same. Not equal to, so we'll be having this symbol and just put a cross over it. It becomes not equal to. As simple as that. Now, the next set of symbols are lesser than. This will be used in a chapter called inequalities in algebra. Lesser than. So when we say x is less than 2. Now, what does that mean? X is less than 2. That means we will consider everything that is less than 2, but not 2. Okay? So it will be minus infinity till till 2, not really, not really. It has to be less than 2. So whenever we use this kind of symbology, less than 2, in terms of if you want to represent some other way, then we'll be using intervals. Those interval will be minus infinity to 2, and I'll use a simple bracket. The simple bracket denotes that these two numbers would not be considered, but everything else will be. I'll give you one more example. So if I say x is less than 3 and greater than 1. What does that mean? That x can be anything more than 1 and anything less than 3, but not 1 and 3. So in terms of interval, we can write it as 1 comma 3. Great. Now greater than, so x is greater than 2. The same way, lesser than or equal to. Now here lies the main thing. X is less than equal to 2. If I write that, what does it mean? In terms of intervals, it will be minus infinity to 2, and 2 has to be included. So we'll put a square bracket over here. So essentially, I'm trying to say when we have to include the extremity, we'll use a square bracket. When we have to exclude the extremity, we'll use a simple bracket. By the way, whenever you use infinity or negative infinity, it is always in open interval because nobody knows where infinity lies. So this is something which must be noted down. It's very important. Infinity is never closed because you never know what is infinity, right? Greater than equal to, same way. X is greater than or equal to 2. This means square bracket, we'll put 2 here. 2 will be included in everything else till infinity. Now infinity is always open. I'll put it over here. So this is going to be used. And if you know these things beforehand, it'll be very easy for you to navigate through the syllabus of CAT and other management entrance exams. Now, coming to the next one. This is set union for U for union and inverted U for intersection. Now, what does that mean? So let us say this is basically a Venn diagram. So let us say that this circle represents a few digits, 1, 2, 3, and this one represents 3, 4, 5. By the way, you can see that there is a common area between both these sets. If I represent this set as A and this as B, so what happens? 3 is common. So union, U for union, union can also be written as A, or I will use A or B. By the way, you can use it like this also, capital A or B. So A or B, that means everything that is in A or B will be a part of this union. So A union B will be equal to this. By the way, what kind of bracket do we put over here? It is a set. It is a set. It's not an interval. So we are taking only 1, only 2, only 3, only 4, and only 5. We are not taking anything else in between. So in that case, we'll use a curly bracket. So now you must be understanding the previous slide. I was using the open bracket, and a closed bracket, that's square one. So to include or exclude the extremities, but in this case, it is set. So only 1, 2, 3, 4, 5 will be considered. Intersection. Intersection, it can also be understood as A and B. Something which is there in both A and B. That is nothing but 3 only. So this is how we use the symbols of union and intersection in set theory. Logically speaking, union is or and intersection is and. By the way, there is more. We also use this symbol A and then we put a dash over there. That is basically A complement, or we can say complement of A. So this will include everything that is not in A. Everything that is not in A. So in A we have 1, 2, 3. What is not in A? It's 4 and 5. Similarly, B complement will be equal to 1 and 2. Great. By the way, if there is a set which has got nothing, it is possible, right? So if I remove this example and take a new example, for example, set A and set B, here we have 1, 2, here we have 3, 4. As you can see, nothing is common. So A intersection B will be called as an empty set. That is what we call it. And the symbol for it is this, which is pronounced as phi. Empty set, it's also called as null set. It's also called as void set. So when a set contains nothing, it will be phi. Empty set, null set, or void set. Great. Now, let us move on to the next series of symbols. So as we discussed earlier also, now I'll be discussing it again. Open interval will use the simple brackets. This closed interval will use the square brackets, which is this. And for a set, we'll use the curly brackets. So repeating what we discussed in the previous slides, I'll give you a few examples. So let's say when I write -2, comma 5. Now what does that mean? That means there is a, let's say this is the value, this can be value of x, any variable. So x can be anything between -2 and 5, but not -2 and 5. All right. So x can be represented as x is greater than -2 and less than 5. Perfect. So in terms of interval, this is what we use. In terms of inequalities, this is what we use. Now we have combined both the concepts and there are two ways of representing the same thing. Square bracket. So if someone says -2, comma 5 in square bracket, that means that x is less than or equal to -2, greater than or equal to -2, and less than or equal to plus 5. So you can see I have used the less than or equal to sign. That means x can be -2 and 5 as well, but not in this case. Curly bracket, if I put -2 and 5, that means it is talking only about -2 and only about 5. Nothing else. Nothing beyond, nothing less. By the way, we can also have the mix of these two. How? If I write a simple bracket, -2, comma 5, a closed bracket. Now, what will this mean? This means that x is greater than -2. Wait, x is greater than, I'll just write again, -2, comma 5. So, x is greater than -2 and less than or equal to 5. Clear? So in this inequality, we have used both the symbols less than and less than or equal to. The same time in the terms of intervals, we have used both of them. Similarly, if I use square bracket, -2, comma 5, and open bracket, that means x will be greater than or equal to -2 and less than 5. So I hope this is clear. Now there'll be no confusion at all. This is going to help you a lot. And tell me in the comments that if it is clear or not. Now, going on to the next one. Modulus and modulo. Wow, this is very important. Normally, you must have seen people saying that, heard people saying that modulus basically gives out the positive value, right? Which in practicality looks correct. But in theory, that's wrong. I'll tell you why. So whenever I say -2 and it's mod, this is a symbol of mod. Two vertical lines and something in between. All right. Mod of -2, it will be equal to 2 only. And mod of +2, this will also be equal to 2. So what is it doing? Is it changing the negative to positive? Not really. Modulus is nothing but the absolute value. Now, what is absolute value? Explaining it further, absolute value is the distance from the origin. Now, what is origin? Origin is basically 0. So if I draw a line like this and represent all the numbers like this is called a number line. So whenever I say that mod of x is equal to 2, then what is the value of x? What do you have to do? From the origin, that happens to be 0. From the origin, if I move two steps in either way, rightwards or leftwards, in both the cases, I am reaching two different positions, that is +2 and -2. That is what the meaning of modulus is. I hope you understood it quite clearly. Cool. Now coming to modulo, we never have to confuse between these two words, these two terms. So modulo is basically a remainder function. So whenever you have to write a remainder, like 7 divided by 3. So this is how we do it. 3 twos are 6 and 1 is the remainder. 3 is known as the divisor, 2 will be the quotient, 7 will be the dividend, and 1 will be the remainder. So as you can see here, I can also write it as 7 is equal to 3 multiplied by 2 plus 1, right? So in a way, if I represent the dividend by capital D, quotient by capital Q, divisor by small d, and remainder by capital R, then we can have a generalized expression that is capital D is equal to small d multiplied by capital Q plus R. This is going to be very important for you. Please note this down. All right. Now, what does modulo do? Modulo is basically a remainder function. So if someone asks you what is the remainder when 7 is divided by 3, the answer is 1. To write it mathematically, what we do? We write 7 modulo 3 is equal to 1. By the way, we don't write modulo. We just take the acronym. We call it mod. 7 mod 3 is equal to 1. Now, why I explain this? But because in short, both are called mod. Nobody calls modulus or modulo. They call it mod. So it depends on the context. When we are using this in numbers, it is talking about the remainders. Modulo, when we are into algebra or coordinate geometry, the modulus, that is a distance from the origin. I hope that is clear. Let us take some more examples of modulo. So when I say 9 mod 2, the answer is 1. It means 9 when divided by 2 yields 1 as the remainder. 10 mod 5 will be equal to 0. Why? Because 10 is completely divisible by 5. There will be no remainder as such. Great. Now coming to the next one. Capital sigma. Capital sigma, like it's a Greek word. So in English, when we say capital D, small d, here also we have capital sigma, small sigma. Capital sigma is basically this. This means summation. This means summation. All right. So it looks like this. If I write sigma, and I write it over here, let's say I write n, sigma of n. N can be anything. So normally they do what they do. Sigma n normally denotes sum of natural numbers. We're discussing this further in the real classes. In the class in which we'll be discussing the sequences and series. Sigma n is basically summation of natural numbers. Or if you have to write 1 plus 2 plus 3 plus 4 till n. So to write this much, it is better to write only this sigma n. And to make it kind of very much crisp and precise, people also use that n starts from 1. So what you write over here, below this line, below the sigma, that is the starting point. All right. If it is not mentioned, then normally it is natural number only, but they try to mention it. Below this, it will be the starting point. That is what sigma summation basically means. Great. We have small sigma as well. This will be used in statistics. It means standard deviation, which is not the part of CAT, but in that this might be important. So we'll leave it for this for now, but this is very important. Now coming to a few symbols used in geometry. Parallel. So two lines are parallel like this. They're parallel. Let's say lines are called AB and CD. So to tell people that they are parallel, we'll write AB and two vertical lines like this is parallel to CD. This is the symbol. This is the symbol for parallel lines. Perpendicular. AB is perpendicular to CD. What does that mean? So if we have two lines, we have CD here and we have AB here. So if AB is making a right angle, that is 90 degree, right angle is 90 degree. Right angle is 90 degree. So AB is making an angle of 90 degree with CD. That means AB and CD are perpendicular to each other. This is what we'll be using. It's quite symbolic, right? Same thing has been used over here. Well, now coming to the next set, similar and congruent. So triangles can be similar, triangles can be congruent. So if I want to write triangle ABC is similar to triangle, let's say DEF, I'll use this. Now this is symbol for similarity, and congruent, I'll explain what is similar and congruent. We'll use this symbol. This basically means congruent. So we have two triangles like this. Let us say that this angle is equal to this angle, this is equal to this angle, and this is equal to this angle. This is how we use the similarity in angles. But you can see that the sides are not equal, but angles are same. So these two triangles look similar to each other, but they are not exactly same. And congruent, they will be looking exactly same. So their angles will be same, the length will be same. To represent the equal lengths, this is how we do it. Put one line in these two sides, two lines here, three lines here. This means the sides are same and the angles will also be same. So it becomes congruent. So now I have shown you how to represent geometrically these lines and the angles and also symbology that we use to represent similar and congruent figures. Great. Now the next one, the ratio that defined the world. Now, why I say that? See, I think, and tell me in the comments if you think the same. The most important invention of mankind is wheel, and the most important discovery is fire. That's what I feel. Tell me in the comments if you feel the same. Why I say wheel? Because of wheel only humans started to travel to farther distances. When we moved a lot of distance, we were able to explore new things, we were able to experiment, we were able to create new things. So wheel was the most important. And by the way, wheels are not yet replaced. They will always be there. So wheel is the most important invention. How they made the wheel. Now wheel is basically a circle. And this whole length, if I break it and make it a straight line, there'll be certain length. This length is called as the circumference, and the longest line segment which I can draw inside the circle will be known as the diameter. Why we call it diameter? Because it breaks circle in two equal parts. So the length of circumference and the length of diameter, their ratio is the most important ratio that define our world. That ratio is called as, no prizes for guessing, it is called as pi. The ratio of circumference to the diameter of a circle. By the way, circumference is 2 pi r and diameter is 2r, where r is the radius. So if we divide these two, I'll be getting pi. So this is where I would like to end the session. And if you have any questions, post your questions here. And also stay tuned to this playlist.